Okay, so the work I'm going to be talking about was done in collaboration with Alex Gaetanides and Antonello Sotju, respectively, in Greece and in Italy. And we were funded by Stavros Niarchos Foundation and DARPA. So one often forgotten fact is that the very large electron currents flow in the brain. They flow throughout the body, but the brain is constantly going. And these are the electron currents that reduce oxygen to water. They're part of cellular respiration. And we're talking 50 amps typically for the brain at rest. It doesn't change very much, actually. We're always thinking. And the reaction is this reaction, O2 plus 4 electrons gives you two waters. This is under 1.4 volts, and therefore there's 70 watts of energy consumption in the brain at any time. In a fly, which I'm going to be talking about, is 1 microwatt for each fly. So the difficulty is detecting these currents because they flow parallel to the membrane, and therefore they're not easy to detect by any voltage measurements or any standard electrophysiology techniques. They flow in mitochondria. So the game changer in this area is this extraordinary effect discovered by Ron Naaman about a decade ago, which is that when electrons flow through a phase that has chirality or handedness, their spins become polarized in the direction of travel. And this has been demonstrated in a variety of systems. The mechanism is still not known. So let me just explain. If you have electron spin energy in a magnetic field, the magnetic field splits the up and down energy levels such that at room temperature, because the splits are extremely small, 0.1 millivolt electron volts per Tesla, you get equal populations. Now, if you have an electron flowing through a protein and getting spin polarized, you're going to have a disequilibrium generated. You're going to have more spins in the upper level. So we thought we could use this and see whether when the spins return to equilibrium, when the electrons leave the protein or travel further, whether there's radio frequency emission. We'd expect emission at about 20 gigahertz per Tesla. Now, we built a resonator. It's a special radio frequency resonator. We put the flies in a Teflon tube, and it's all shielded and within an electromagnet. And this is the electromagnet, which is inside a Faraday tent. And to our surprise and delight, we found that there was in fact radio frequency emission from about a dozen flies in the tube. And it was tuned to a particular, in this case, the 900 Gauss, which is roughly where it should be if it were a free electron. So what's happening here, I just want to emphasize, we're not putting any energy into the flies. We're not putting radio frequency. We're just measuring emission. And we get a pretty good signal. And when you put chloroform, you inject chloroform into the tube, the signal goes away. Now, this told us this might be the nervous system involved. And so what we did was we used genetically engineered flies. Look at the two right-hand most containers here. These are flies that have ion channels in their neurons that are turned on by high temperature. So the ones, the two on the right are having convulsions when you raise the temperature. So the question was, do the emissions from the flies get bigger when you raise the temperature in the resonator when the flies have these special ion channels? And the answer is yes. So here we have the flies in a resonator. We start at 4 centigrade, where they're pretty much inactive, and then we ramp up the temperature inside the resonator. And when it gets to about 21, 22, you start seeing bursts of radio frequency coming out. And I say bursts because there's a lot of fine structure to these radio frequency signals. They're short blips. And as the temperature goes up, the bursts get bigger and bigger. So this is the spectrogram of these bursts. You can see there's a lot of activity at 30 hertz, but there's actually activity throughout the spectrum. This was published in the archive, and you can go look at it. We're now building a bigger magnet to put people's heads in. This is a magnet with one solenoid and 2 Helmholtz coils, and we're going to be measuring the emissions from humans very soon. Thank you so much.